Hey YouTube, JGreen302. I think I'm going to call this solar panel wrap up. Wanted to give you guys an outside view while the sun was shining, no clouds, no rain. You will notice we've got 400-watt panels and a 60-watt array. I wanted everybody to see this. Wanted to show how simple this is. You'll note the wood. You will note the wood. The wood cost $4 total for this. You will note that both panels have the negatives and the positives joining together in series. And look at this. These are that simple on an extension cord. It's hard to do one-handed. Simple connections, positive and negative, to an old extension cord. Both panels are set up this way, so now you see one, you see both. I take this, pull it out, lift this whole panel. I can walk it away. I can move it, I can do whatever I want to do. Extension cord gives me plenty of room. $4, torn up extension cord, repurposed. I think $12 for the joiners, about $250 for the panel, per panel. I've now explained everything you need to know about the 400-watt panels. So, one pair, two pair, 60-watt panel. That's it. Just feeding everything in. Let's go take a look at the controls. Alrighty. Well, sun shining, that's good. Sun shining, it kind of causes a problem. Let's see if that'll change anything. Nope. Dry locked the entire place to make sure that we had no excess moisture. Placed the batteries down below. That's 5 marine batteries. 125 amp hours apiece, all in series. That is bank A. And then here I have a secondary bank. And I'll show you what I did with it. So let's start with the big panels. 4 100-watt panels. Called it the primary array. I've got my grid set up here. I made my own control panel. This material, this hardboard, $8 for a huge sheet to make the control panel. Radio Shack for some LEDs, $5 a piece at Amazon, $30 I think for the charge controller. And basically very simple electronic work. I made sure that I sized these to what I was planning on doing, which was 10-15 amps. Basically I'm treating it like a car wiring system. Nothing special. I'm not going to go past a certain amperage, so I don't have to worry about the wiring. I've got it set up so I can kill the power to the whole board. I have a diversion switch. I wired the LED so that in the morning when the LED starts glowing, I know that the sun is coming up and we're producing power, because this LED lights from power production on the panel. It goes dark at night. I can turn the system on. You can see we monitor voltage, but we have no amperage because we're not giving it a load. I can switch the load to the batteries. You'll see the LED lights up and it starts charging that big bank of 5 marine batteries. And so it's throwing all this power to the batteries to charge the batteries. And every once in a while I do this to top those batteries off, but for the most part I'm not cycling those batteries. It's there for emergency use only. So most of the time I run it in grid tie mode, and you'll notice as I throw it to the grid tie, amperage starts going up because it can throw a bigger load. Very simple. I can trace my power from incoming power on through the amperage, through the voltage, over to the grid tie, and in which direction it's going. Exact same setup here. I can follow my power. I can switch, charge my batteries. I can switch, throw it to grid tie. And then what I've done is this, when it's in the down position, the wires go straight to the battery. When it goes to here, it joins on that side with the grid tie, so that the cumulative gets supplied into this gauge, out of this gauge, directly to the grid tie. I also built monitors for both battery banks to make sure I can tell that they're fully charged or if they're, on the decline. And from there, when it comes out of this meter, it goes to the grid tie. And you can see how it's going. And I have it coming out, and I got it into a kilowatt meter. I just added the other two panels. I was averaging about 5 kilowatts of power back into the house a month. I expect it to be up to 10 kilowatts now that I've added the other two panels. And if the electric goes out and everything goes bad, just reach over here, and all of a sudden I've got power inverter off those batteries. Sweet. So let me turn that off. Here's the grid tie inverter. Cable's running back to an outlet in the house. It's like an 11 amp circuit. I don't know if you guys can see that. There it is. That's 11 amps for the majority of the day the sun is shining. That's an 11 amp circuit feeding power full time into the house. That should more than offset lights, clocks, cable boxes, all the little stuff. I'm accounting for all of that, and plus anything else this house is using. It's a 10 amp circuit all day long, reducing my electric bill. So every day from here on out, as that sun shines, I'm dropping my electric bill. I'm doing it fairly substantially. I'm going to monitor this for a little while, and if the electric goes out, there is a lot of batteries down there to make sure that I can run lights and anything else I got to do. I think that this is an awesome shit hits the fan prep. It's a little bit expensive and it took a lot of work, but for the most part, I have a prep sitting here, charged, ready to go in the event that something goes wrong. And by the way, if you notice how the whole thing is set up, in 15 minutes I can have this all packed up in my truck and I can haul ass with it. That's another nice little feature about this. Nothing is permanent, everything is mobile. And when I'm not using it, all this money and this gear is doing nothing but working full time to sit down and throw 11 amps of power back into my house to reduce my electric bill and save me money. And I thought that this was an awfully nice setup, and I am very pleased to say that I'm actually proud of this. I thought I'd show everybody. I really liked this project. I enjoyed it. Thought I'd show everybody the end result of all that work from start, and now you get to see finish. Thanks for watching, folks. I hope you enjoyed the video.